Factoring C2. How to factor trinomials like ax squared plus bx plus c? Well, we have two examples here. And with these examples, I'll try to explain you the process. Well, C for me is communication, and you should really see through the process. That is the whole concept here, right? Now, in C1, you saw that to factor, we can apply sum and product method. Now we'll apply the same method here also and see whether it works or not, and how can we make it work. That's the whole criteria. So now what we will do is, there is one difference between the examples which we took in the previous communication question C1 and in this one. Here a is not equal to 1. Especially a is not equal to 1. A is some other value but 1, right? Like 3x squared. 3 is the leading coefficient, right? Here it is 2. The leading coefficient a is not 1. It is 2 here and 3 here. Well, a is also called leading coefficient. Remember that term. So a is leading coefficient. Okay, so at times it may not be just a quadratic equation. It could be of degree 10. Then the leading coefficient is the number or the coefficient of x to the power of 10. Okay, now let's go through this process of factoring here. So what we are looking for is sum and product. That means we need two numbers whose sum is 14 and whose product is the product of these two numbers. In previous example, this was 1 and therefore we just took c, right? Strictly speaking, it should have been a times c. But previous example, a was 1. So 1 times that number gave us c only, right? So the strategy here is sum and product. So that means we are looking for two numbers, let's say p and q. So where p plus q should be equals to the middle number, the coefficient of x, which is 14. And the product, p times q, should be equals to product of 3 and minus 5, which is minus 15 for us. Now, I'm calling this method sum and product, but I'm really writing product first and sum later. There is a reason for this. To get sum of numbers which will give me 14, I got huge choices. 1 plus 13, 2 plus 12, 3 plus 13, I mean, you know what, right? So there are so many choices, right? There is no end to it, right? So, but for product, we have only limited number of choices. Therefore, to start with product, it is easier for us, correct? So we'll start with product and then find if we could get the sum of 14. So we can start with, let's say, 5 times 3. 5 times 3 is 15, but when you add 5 and 3, you get what? 8, not 14. One more important thing here is, if your product is negative, that means both the numbers are of different sign. One of them is positive, one of them is negative. Second important thing is, when you add and get positive, that means bigger number is positive. So right. So that means we are looking for two numbers whose values are plus and minus, and they add up so that positive is higher. So with 15, the choices are 1 times 15, right? One choice. 3 times 5. Well, there are very few choices. 1 times 15. Does that work for you? I think it does. So what we should do is, let's try it out. So if I write 15 and 1, I have to make one of them of opposite sign, because when I multiply this, I'll get positive. So I have to make minus 1, since addition should give me positive number. So bigger number is positive. And when you add 15 and minus 1, you do get 14, right? So that is the right choice. So what we do here is, we decompose the x term and write it in terms of 15 and minus 1. So we'll do that, and I'll show you how to proceed from here. 3x squared plus, instead of 14, I'm writing 15x minus x, right? 15x minus x is 14, right? So that is how. And these are my two magic numbers whose product is 3 times minus 5 and whose sum is 14. Now I can do grouping. So I can group these two and these two. See what happens. 3x is common here. So when I take 3x, I'm left with x here and 5. X plus 5. Here we don't have anything common, so minus is always common, -1 or +1, right? Since the sign is minus, I'll retain this sign and open the bracket to put them like in this way. So it becomes x plus 5. Well, if you open -x and -5, it gives you the same thing, right? So we see that the expression is exactly the same expression. So these are two equivalent expressions. Now from here, we can take x plus 5 common. So we get x plus 5 and we are left with 3x and here -1. So that is the factored form of the given question, correct? If you want, you can check it. So checking, I'm leaving it to you. Just expand and check. Do you get the same answer or not, right? So check portion, I expect you to do. Let me do the next one again for you. Now here, as I said, we are looking for two numbers, p and q, whose product should be how much? 2 times 9, correct? So, we are looking for two numbers, p times q, whose product is 18, ac, a times c, okay? And whose sum, p plus q, is 9. Everything is positive, all numbers related will be positive. So the numbers are 18, we've got limited choices. That's why I write product first and sum later, correct? 1 times 18, 2 times 9, 3 times 6, well that's it. And 3 times 6 gives me 18, plus 3 plus 6 is 9. So my numbers are 3 and 6, right? So I can always break 9x as 3x plus 6x. So let me show you how we'll do it further. So we get 2x squared plus, so I got 3 and 6. I prefer to write 6 first since this is even. So 6x plus 3x is my 9x, correct? Plus 9. Now we can group them. First two numbers will give me a common factor of 2x. I'm left with x plus 3. And here we can take 3 common. We are left with x plus 3. Always this has to be same. If it is not same, that means you made a mistake. Check it out. Okay, that is important. Now here we can take x plus 3 common, get x plus 3, and we are left with 2x plus 3. So that is the answer for us. Now, will you like to check this one also? Okay, let me check at least one of them for you. So let's do distributive property, okay? Now, first in, first out also you can do whatever, and we'll do distributive property. I prefer that. So we'll go x times 2x is 2x squared, x times 3 is plus 3x, 3 times 2x is 6x, 3 times 3 is 9. Now if I add the middle two terms, I do get 9x, and here we have 9. So do you see? You can compare this and this. Exactly same. So our factoring was perfect, and this product and sum method really works. So product and sum method always works for trinomials, right? So as a rule, for trinomials, right? What method to apply? Should I call it product and sum now? Okay, because I do product first. I'll say product and sum. But either way, it gives you the same result. I hope you understand and appreciate it. Please share it with your friends and go through this communication question list and then do worksheets and then tutorials. In worksheets, I have purposely kept just 4 questions. I've seen some students, they can't really work for more than 15 minutes. Tutorial sheets are longer. Okay, all the best. Thank you.